Hey guys, okay, so we're going to do lesson 2-2, so lesson 2 of topic 2. It is called 9 as a factor. So by the end of this lesson, we're going to be able to say we can use patterns to multiply by 9. Okay, so let's go ahead and start with our solve and share. All right, so our question asks, Maria bought 4 packages of bottled water. There are 9 bottles in each package. How many bottles did Maria buy? Explain how you solved this problem. Okay, so if I were going to go and solve this problem, I would use an array, just like what they've started, in order to answer this correctly, okay? Now, I'm going to use a different color than they did, just so that way I can keep straight what color mine are versus what theirs are. But let's go ahead and add to this array. So they already have one group of 9. We know that we're going to need a total of 3 more groups, right? Because there's a total of 4 packages. So I'll start those first 3 ones, because now there's going to be 4 packages. We can keep adding circles to our array, fleshing in those 9 total per line. Fleshing means just adding in those 9 total per 9. Fancy word for that. Okay. If it helps you on your paper, you can also draw a line between them to keep them separated into their own little packages, because that gives us a total of 4 little packages here. Now what we have to do is we have to basically count them up, okay? If we know that this first group has 9, we know the second group has 9, the third one does also, as does the fourth one. We can join some of these together to make our multiplication / high-speed addition easier to do, okay? We know that 9 and 9 together make 18. So we can put 18 over here. We know that another 9 and another 9 also make 18, okay? So I'm basically splitting my groups from 4 of them into now sticking 2 and 2 together. So 18 and 18 together, 8 and 8 make 16, so we put 6 here, carry the 1. Now we have 3, giving our answer of 36 total bottles, okay? So I used an array here in order to solve the problem by simply laying out the 9 across the 4 different groups, joining 2 of those groups together, joining the other 2 groups together, and then ultimately joining all of it back together. A quicker way to count them. You could have also counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on until you got to 36, but multiplication or grouped addition, like what I did just here, can really help us out here, okay? Otherwise, it would be 4 groups of 9 for multiplication to help us, because there's 4 packages, 9 bottles in each package, equals 36. Okay? Now we'll be talking about the number 36 and the other factors of 9 here in just a little bit. But starting with an array is a good way to kind of organize our thoughts visually, and then we can transfer into the more multiplication problem set up like this. Okay? So let's go ahead and go on. Now we have our visual learning.
How can patterns be used to find 9's facts?
Well, there's many different patterns here, right? If we go up by 1, so up by a factor of 1, so times 1, times 2, times 3, times 4, so on and so on, it's multiplied by 9 all the way down. So 9 times 1, 9 times 2, 9 times 3, so on and so on, okay?
9
Okay, it says 9 roses were put into each package for sale at the Florian. So talking about the 9 roses were put into each package for a sale at the Florian Botanical Gardens annual gift and plant sale. How many roses are in 8 packages? Okay, so we know that there are 9 roses and 8 packages of those roses.
Roses were put in each package for sale at the Florida Botanical Gardens annual gift and plant sale. How many roses are in 8 packages? How many roses are in 1 package? Select your answer.
We already said that, right? If we reread the question, it says 9 roses were put in each package for sale. So that means we're looking for the 9.
Look at the table of 9's facts. 0 times 9 equals 0. 1 times 9 equals 9. To find the next multiple of 9 in the table, you can add 10 and then subtract 1. When you add 10, increase the tens place by 1. When you subtract 1, decrease the ones place by 1. 8 times 9 equals 72. There are...
If you ever want to double check your math to make sure that you have the correct number, if you look at our numbers here, you see how 0 times 9 is 0. 9 times 1 is still 9, right? Any number here in this pattern, with an exception to 0, which anything times 0 is still 0, will add up to be 9, okay? It would be like saying 0 tens, 9 ones. Well, 9 ones is still 9. 1 10, so 1, and 8, put them together, make 9. 2 and 7 together make 9. 3 and 6 together make 9. The digits of each one of our facts here on the right will always, when put together, just the digits, not the actual total, but the digits, when they're added together, like 3 and 6 together make 9, 4 and 5 together make 9, 5 and 4 together make 9. All those digits will add up to be 9. Okay, that's how you can double check if you're on the right track or if maybe you skipped something somewhere as well.
72 roses in 8 packages of 9 roses. Here is another way to solve the problem. Start with 0. For each group of 9, add 1 10 and subtract 1 1. 10 minus 1 equals 9. For 8 groups of 9, add 8 tens and subtract 8 ones. 8 times 9 equals 80 minus 8. 8 times 9 equals 72. There are 72 roses in 8 packages.
Okay, so what they did there was, instead of multiplying by 9s, which can be a little hard, I'm not going to lie, they went and multiplied by 10s instead, and then just took away those extra ones from each one. So again, they multiplied 8 by 10 here, which gives us 80, and then took out 8 ones because those are 8 extra ones that we didn't need to multiply by, giving us a total of 72. Okay, so those are 2 different or 3 different ways that you can actually arrange things in order to solve a 9-factor problem. Let's go ahead and go on to our practice. Okay, so this is the convince me part. It says use patterns to find 9 times 9. Explain how you found the product. So if we were going to do this, right, and a moment ago they told you the 10-factor version instead, if we multiply 9 by 10, right, that'll give us 90. And then we take away those 9 extra, it'll give us are 81. See how quick that was? Instead of going 9 plus 9 plus 9 all the way out to 9 spaces. Yeah, a lot quicker to multiply by 10 and subtract, or to multiply directly, okay? Okay, so on your pages, which are page 47 and 48, for the guided practice, it says, Paul thinks 3 times 9 is 24. Use a 9's pattern to show that Paul is wrong. Okay, so I'll do this first one with you. If he says that 3 times 9 equals 24, we already know it's wrong because remember how I said those digits would, when put together, would make 9? Well, 4 and 2 together only make 6. So something around here isn't quite right. We can also prove him wrong by showing him that we know what 2 times 9 is, and it's 18, right? If we already know what 2 times 9 is 18, and we wanted to find 4 times 9, we just make the 2 times 9 twice and add them together. So again, going back to our addition section over here, coming up to 36, we can say 4 times 9 is 36. Okay? So we know for a fact that he was wrong here because 24 is not 9 less than 36. It's also not 9 more than 18. Okay? That is how you can prove, using a pattern here, that he was wrong in this case. Okay? Then it's going to ask you to look at the table of 9 facts we just talked about on our last page, so page 46, I believe. It says, look at the table of 9 facts on the previous page. Describe a number pattern in the multiples of 9. Well, like I said before, they're all 9 apart. They also have their digits, when put together, would equal 9. So, for example, 36, 3 and 6 put together would equal 9. 8 and 1 put together would make 9. You'll find that as a common pattern throughout the entire 9 multiplication fact table. Okay? This is actually part of what would be independent practice. Okay? So you're going to tell me what 9 times 2 is. Hint, hint, we've already done it. You're also going to show me how maybe counting by 9s isn't the best option. Sometimes using the other factor in a multiplication problem is an easier number to multiply than the larger number, in this case 5. You can count by 5s a lot quicker than you could count by 9s unless you've got it memorized, okay? On number 5, I challenge you to use the 10, like the multiply by 10, and then take away the 1s method to solve 7 times 9. And then I challenge you to use the repeated addition, either an array if you'd like to, or just repeated doubled addition to solve 4 times 9. Okay? Hint, hint, we've also solved this one as well on this page somewhere. Okay, and then again, 2 times 9, kind of jumping back on itself from number 3. So go ahead and finish in the Did You Know section as well as the independent practice. If you guys have any questions, comments, or concerns, please have Mom and Dad let me know. Call, text, email, Dojo, anytime. I will get back to you as soon as I can. So see you next time, guys.